Hi everyone, my project is titled Roshni for Pakistan. Roshni means light in Urdu, and since my project aims at saving enough energy to provide light in dark for students to study in Pakistan's rural areas. As we can see here that there is an energy crisis in the developing countries, it can be seen from the table below that is not strictly due to the deficit between energy production and demand because we can clearly see that the deficit is not huge. Still, most of the rural areas in all these three countries have no electricity most of the day. The economies of all these developing countries are already very weak. These countries have to prioritize immediate problems such as hunger, disease control, and so on before they can save some money to spend on installing expensive power units and expanding power lines. So the question comes that how can people help to reduce this problem? We can all turn off unnecessary appliances, but as humans, can we expect ourselves to do that? So the question arises, what can we actually do to solve this problem? So we have got three options, which are either we turn off appliances when not in use, or we use modern energy efficient appliances at our homes, or the third option is that we use smart technology to turn off the appliances when not in use. Modern energy efficient appliances are extremely expensive in Pakistan. Currently, Pakistan does not manufacture nor design any smart automation tools. All the smart home technology is imported from developed countries such as USA or China, where the import taxes and the tax duties are very heavy. The cheapest home automation solutions, Okasha Smart in Pakistan, cost around $100 per room, where you've got four lights, one fan, and one TV on average. And the labor is extra. Average yearly earnings of a household in Pakistan are about $587 according to CEIC data. Pakistan has no strict energy saving policies. There's no Energy Star rating for all the appliances manufactured in Pakistan, and all the imported energy efficient appliances are extremely expensive due to the heavy taxes and the fees levied on them. As we can see clearly here that a local refrigerator with no Energy Star rating cost about $224, while an imported one cost about $1,256. Considering the weakening economy, the exchange rate of USD to PKR keeps increasing daily and has increased over 60% over the past 2 years. Hence, our solution is cheap home automation. We are living in the fourth industrial revolution. Our lives are becoming more comfortable and smarter with the help of rapid upgrade of technology. IoT is playing a massive role in this. One of the major sides of IoT is a smart home. As we are in the era of never ending growth of the internet and its application, smart home system or automation system is highly increasing to provide comfort in life and improving the quality of life. This paper basically presents an IoT based low cost smart home automation system. This system is based on a web portal which is controlled by ESP32 Wi Fi module. Also, a custom made private home web server is developed for maintaining the current states of home appliances. A cheap home automation setup was made using ESP32 and QTT server and Arduino. How ESP32 with Wi Fi helps control normal electrical devices remotely. The ESP32 connects to a server where the algorithm and command is executed. The final data of the result is sent to the Arduino and finally to the relays, which turn on and off the lights and the fans depending on the command. Setting this up on the public IP address helps control and monitor everything in the house from anywhere in the world. This helps understand how cheap and easy this is to implement it in any house. The reason why this served as an inspiration was because these two researchers developed this project due to the energy shortages in Bangladesh. Both Bangladesh and Pakistan are very similar countries, so a similar setup can actually be applied here in Pakistan as well. The second project was by Alex Vendy from Buffalo University. This served as an inspiration because taught me how cheap and easy it is to automate common electrical appliances at home. He uses Home Assistant, ESP32 and MQTT server for his automations. This served as a great introduction to Home Assistant and the ease it brings when it comes to home automation. I will be using Home Assistant as the base of my project. Integrated in the Home Assistant would be the ESP Home add-on, which would allow me to send and receive signals to my ESP devices. The Home Assistant would be installed on Raspberry Pi 4 on Ubuntu server so that the server can remain on and use less energy. The Home Assistant is basically a free and open source home automation software written in Python designed to be the central control system in a smart home or a smart house. It has a number of add-ons including system integration with different IoT technologies including Google Home, etc. The Raspberry Pi will basically create a server on we are going to create a server on Raspberry Pi with Home Assistant supervised installed in it. One Raspberry Pi is required for one home. Our ESP32 modules will interact with Home Assistant on Raspberry Pi to perform tasks such as turning on and off the lights. ESP Home is basically it's the Home Assistant's add-on. Since we are using ESP8266 or like at times 32 Wi-Fi modules, this add-on will allow us to set up, manage and control all the ESP8266 or 32 with Home Assistant. Basically ESP8266 or 32 will be used because as it is having Wi-Fi functionality, ample processing power and add-ons available on Home Assistant. This is the flowchart of the design. Sensors would detect and transmit the data to ESP32, which would transmit the data through Wi-Fi to the Raspberry Pi server. The data would be received by Home Assistant, and depending on the data type, it will execute on an automation algorithm, and the resultant data would be sent from Raspberry Pi to ESP32 via Wi-Fi, after which the ESP32 will execute its command. This is basically how I approached the project. I started by first learning about Home Assistant and setting it up on Ubuntu server in Raspberry Pi. While the Home Assistant can be installed on Raspbian, it is not supported. After installing and setting up Home Assistant, I started with understanding how coding is done in Home Assistant. Home Assistant uses YAML syntax to coding. I first installed ESP Home in Home Assistant. The reason behind installing ESP Home is that it makes it extremely easy to code and automate, and there is no need to set up a separate MQTT server for connection between devices, which we saw in all the projects which I discussed earlier. The best part about the ESP Home, which I will demonstrate in the coming slides, is that it will require little to no programming knowledge to understand. All we need to do is fill a form and the code is generated itself. We created a node first. A node is defined as basically an object you want to automate, such as a light. I first automated my lights, after which I moved to a fan automation similarly. The next thing was PIR control of the lights and fan, which was extremely easy as it required me to add another sensor device in ESP Home, for which ESP Home generated a code which I added to my light and fan automation YAML code. Next, I added a temperature sensor in a similar manner to control the fan. Lastly, I integrated all the system together for final testing. This slide basically shows how easy it is to code in YAML using ESP Home. I choose this device, enter the required information, and it sort of generates the YAML file. Then I'm free to add the codes for sensor in the sensor portion of the YAML file. This is my final circuit. I used 4 channel relay to automate 3 lights and a fan for one room. The ESP is not connected with a USB power, but rather it is dedicated 3.3 volt power supply. I use a dedicated 220 volt to 3.3 volt AC to DC converter for the ESP Home. Even though the ESP can also be powered using a 5 volt AC to DC converter, but the ESP's required voltage is only 3.3 volt, and it converts internally 5 volt to 3.3 volts. I initially used HLK 01 220 VAC to 5 volt DC module. The AC lines of the module were extremely close and the module was a bit expensive, so I didn't use it for the final version of my project. This module is economical, compact in size, has low input and output noise, and can easily be mounted on a PCB. The downside is that this module has no shielding of components, so it's best if it is not handled by non-trained people. For the PIR motion sensor, I initially opted for the HC SR501 motion sensor, but upon observing the log data from the sensor in the ESP Home, I observed that the sensor was giving out many false positives. So I replaced it with a more accurate AMT 302 sensor, which had minimum false positives, was highly accurate and compact in size. The downsides were that it was more expensive than the HCSR 501 and still had a few false positives. It wasn't perfect. I opted to use the AM3202 temperature and humidity sensor for temperature monitoring. This sensor was extremely expensive, but it was highly accurate and compact in size. For my test setup, I used two identical rooms with identical number of lights. Since it was winters, there was no need for a fan automation, so I only observed the lights. In one room, I deployed my smart home setup while I left the other as it is. The room was used for on average for 5 hours a day. Both subjects used the room for approximately identical times. The subjects were allowed to leave the room for 2 water breaks, each lasting 4 minutes, and 2 regular breaks, each lasting 10 minutes. The rooms had attached bathroom and each subject was allowed one bathroom break 5 to 10 minutes long. The results can be seen here. The numbers mentioned on the top of the bar chart are all in joules. It can be clearly seen that the smart energy usage is on average 15% less than a non-smart usage. Considering Pakistan's energy usage, which is 25,000 megawatts, and if 20% of the households employ this method, a total of 750 megawatts could be saved. The electricity consumption per capita in Pakistan is 103 kilowatts per capita. This means 7,281 more people can get access to electricity with this system if only 20% of the households employ this system. The total cost of this system is about $14. The average income in Pakistan is about $420. Hence, this system is quite affordable as compared to the system supplied by imported smart home companies. The energy savings are 15% on average in winters, with 25% projected savings in summers, as fans use more energy than the LEDs. Among the cons of this system are that the initial server setup may be confusing for some people, and the sourcing of some parts, such as temperature, is difficult in Pakistan. This is the PCB designed constructed on Eagle. For future works, I hope to integrate a light sensor in the setup. mass produce the product for cheap cost, custom design a beautiful and sustainable outer shell for the product, and add dimming ability for fans and lights in the setup for more energy saving. Now I will be showing the demo to you, as after this slide a video will be attached for the demo. Thank you.